Hey everyone, and welcome. Today, we're going to demystify a piece of tech that quietly powers so much of our digital world, from huge data centers all the way down to maybe even your own home server, and that is RAID. So, what is it, really, and why should you care? Well, let's dive in. But first, let's start with a quick thought experiment. What would happen if the hard drive that holds all your precious photos, your critical work files, your entire digital life, what if it just died right now? It's a terrifying thought, right? And that is the exact problem that RAID was invented to solve. To really get why RAID is such a game changer, we first have to understand the problem. A single hard drive is, well, it's a single point of failure. When it goes, everything on it is gone. Plus, it's only as fast as it is. So how do we work around these limits? We do it with RAID, which stands for Redundant Array of Independent Disks. Now, that sounds super technical, I know, but the core idea is actually really simple. You take a whole bunch of physical hard drives, and you use this technology to trick your computer's operating system into seeing them as just one single, super-powered disk. Okay, so you've probably heard people throw around terms like RAID 5 or RAID 10. But before we get into all those numbers, we need to understand the three fundamental techniques, the basic ingredients, really, that all of these different RAID levels are built from. First up is striping. Imagine you have two chefs, and you need to chop a mountain of vegetables. If they both work at the same time, the job gets done way faster, right? Striping does the same thing with your data. It writes little pieces of it to multiple disks all at once. It's incredibly fast, but, and here's the catch, if one of those chefs just walks out or one of your disks fails, the whole meal is totally ruined. All speed, zero safety. The second building block is mirroring, and this one is the complete opposite of striping. Think of it like making a perfect photocopy of a super important document. You write the exact same data to two separate disks at the same time. If one gets lost or destroyed, hey, no problem, you've still got the perfect copy. The big downside? You have to buy 2 terabytes of storage just to actually use 1 terabyte. You're paying for that peace of mind. And our third technique is parity. Now this one is really clever. Imagine a Sudoku puzzle. If one number is missing, you can use the logic of all the other numbers in that row and column to figure out what it was, right? Parity is kind of like that. It's this extra, mathematically calculated information that allows the system to rebuild the data from a failed drive using the data on the other drives. It's a brilliant way to balance safety and efficiency. So here's the crucial thing to remember. It all comes down to this fundamental trade-off. On one hand, you've got pure, unfiltered speed with striping. On the other hand, you have maximum safety with mirroring. And somewhere in the middle is that clever balance of parity. Every RAID level we're about to talk about is just a different recipe using these basic ingredients. Okay, so now that we know the ingredients, let's look at the most popular recipes. These are the common RAID configurations you're actually going to see out in the real world. First up is the Speed Demon RAID 0. This configuration has one goal and one goal only, and that is to go as fast as physically possible. RAID 0 uses only striping. With at least 2 disks, you get absolutely blazing fast performance. This is fantastic for things like video editing scratch disks, or maybe loading your video games, stuff that you need to access quickly but could easily get back. But, and this is a huge but, if a single one of those disks fails, you lose everything, all of it, across the entire array. It's the definition of high risk, high reward. All right, let's slam on the brakes and swing to the complete opposite end of the spectrum with RAID 1. This one is all about playing it as safe as possible. RAID 1 uses only mirroring. You get excellent fault tolerance, a drive can literally die, and your system won't even hiccup. This makes it absolutely perfect for your main operating system disk or for critical databases. The cost, of course, is that you only get to use half of the total disk space you paid for. It really is the price of peace of mind. Okay, so what if you don't want to choose between pure speed and pure safety? Well, that's where RAID 5 comes in. It is one of the most popular configurations out there because it tries to give you a bit of everything. RAID 5 is so smart because it combines that fast striping with the clever parity calculation for safety. And as you can see, the parity information is spread out across all the drives, so there's no single bottleneck. You get good performance, really efficient storage use, and you can lose any one disk without losing your data. It's a total workhorse for things like file servers. But what if being able to survive one disk failure just isn't enough protection for you? I mean, what if you're storing truly irreplaceable data and you're worried about a second drive failing while you're busy rebuilding the first one? For that, we have RAID 6. RAID 6 is basically RAID 5 on steroids. It calculates and stores two sets of parity information. This means it can withstand two simultaneous disk failures, which is an incredible level of protection. The trade-off is that all those extra calculations slow down the write performance, making it ideal for large, mission-critical archives, data that you write once and then just need to read many times. So we've seen speed, we've seen safety, and we've seen a balance. Let's put them all side by side. And then let's look at one more special configuration that really tries to deliver the best of both worlds. Now, what I love about this chart is how clearly it just lays out all the choices for you. You can just trace the lines, right? If you want the absolute highest performance, that's RAID 0, but you're accepting 0 fault tolerance. Want the most fault tolerance? Look at RAID 6, but be ready for slower writes and needing more disks. It's all about picking the right tool for the job. And this brings us to the powerhouse RAID 10. You might also see this written as RAID 1 plus 0, and that 1 plus 0 is the key to understanding exactly how it works. It's not one single technique, it's two of our building blocks combined together. And this just shows you the process perfectly. First, you take pairs of drives and you mirror them, just like in a RAID 1. That is your safety layer. Then you take those protected, mirrored pairs and you stripe your data across them, just like in a RAID 0. That's your speed layer. The end result is an array that is both extremely fast and extremely safe. Though just like RAID 1, it comes at the cost of half of your storage capacity. We're almost at the end, but I have to leave you with the single most important and honestly the most misunderstood point about this entire topic. So please, listen closely to this next part. RAID is not a backup. Let me say that again. RAID is not a backup. RAID is a system for fault tolerance. It protects you from a physical disk failing so your system can keep running. It does absolutely nothing to protect you if you accidentally delete a file, if you get hit by a virus, or if your house catches on fire. For that, you need a separate historical copy of your data. You need a backup. So we've explored the building blocks and the most popular recipes for managing our storage. We've seen that constant trade-off between speed and safety, and we've learned the critical difference between fault tolerance and having a real backup. So the only question left is, with this knowledge, how will you choose to protect your own data?